In section 2.1, we talked about how to organize qualitative data. In section 2.2, we are going to talk about how to organize quantitative data. So in summarizing quantitative data, we first determine whether the data are discrete or continuous. So hopefully everybody remembers discrete data are things we count, and continuous data are things we usually measure. So if the data are discrete with relatively few different values of the variable, then the categories of the data, which we call classes, will be each individual observation. If the categories are discrete but have many different values, or if the data are continuous, then the categories of the data, remember we're calling those classes, must be created using intervals of numbers. And an interval is just a range. So for example, 20 to 25 is an interval. So how do we organize discrete data in tables? Well, we can use the values of the discrete variable to create the classes when the number of distinct data values is small. And distinct means different. So if we look at our Wendy's arrivals numbers here, our smallest is 1, and our data values go all the way up to 11. So we could have 1, 2, 3, 4, 5, etc., all the way up to 11. So each number of customers is one of our classes. Then, just like before with the categorical data, we count how many fall into each class. So there was one 15-minute interval that only had one customer. There were 6 15-minute intervals that had 2 customers. And so we're literally just counting. So there's 1, 1. There are 1, 2, 3, 4, 5, 6 twos. And we carry on until we have all the numbers taken care of. The relative frequencies, remember, they get by doing the frequency of the class divided by the total number of observations. So 0.025 is 1 over 40, and etc., etc. So like if we look at the class 5 customers, its frequency was 7, so that's 7 over 40. And that's how they got the 0.175. So creating a frequency and a relative frequency table for discrete data, as I said already, was the same as when we were dealing with the qualitative or categorical data. So let's talk about histograms of discrete data. A histogram is constructed by drawing rectangles for each data class and the height of each rectangle, just like in a bar graph, is either the frequency or the relative frequency of the class. The width, of course, of every rectangle is the same, just like in a bar graph. But this time the rectangles touch each other. So in a bar graph, let's go remind ourselves, a bar graph, the rectangles don't touch. They're separate. In a histogram, they're going to look like this. They will touch each other. Otherwise, a histogram is exactly the same as a bar graph. So let's make a frequency histogram and a relative frequency histogram using our data from those Wendy's drive-thrus. So again, we should have a vertical and a horizontal axis here. And I'm going to use blue for my bars. So one customer had a frequency of 1. So there it is. 2 customers had a frequency of 6. And you can see I'm going from halfway between each number. That's the width of my bars goes from halfway between 1 to halfway between 2. I mean halfway between 1 and 2 and halfway between 2 and 3. So carrying on, 3 had a frequency of 1. 4 has a frequency of 4. 5 has a frequency of 7. 6 has a frequency of 11, so all the way up to the top. 7 has a frequency of 5. 8 has a frequency of 2. 9 also has a frequency of 2. 10 has a frequency of 0, so we just don't put a bar there. And we pick back up with 11 has a frequency of 1. Now remember, our relative frequency histogram should look pretty much the same in terms of the relative heights of the bars. It's just we do it by relative frequency instead of the frequency. So one customer has a relative frequency of 0.025. 2 customers has 0.15. 3 customers is 0.025. 4 customers is 0.1. 5 customers is 0.175, which is halfway between 0.15 and 0.2. 6 has a relative frequency of 0.275, which is halfway between 0.25 and 0.3. Then we have a 0.125, which is halfway between 0.1 and 0.15. So that's 7. 8, we have 0.05. 9, we have 0.05. 10, we have 0, so we don't draw a bar. And 11, we have 0.25. So again, you can see here that the relative heights of the bars are the same between the frequency histogram and the relative frequency histogram. 6 customers has the tallest bar. 10 customers has no bar because there were no 15-minute intervals that had 10 customers. We'll end this video here, and we will pick up with some definitions in the next video.